Hey guys, it's Sean from Crafted Elements, and in this video we're going to be doing a complete assembly of the Crafted Elements router sled, or slab leveler if you will. Of course, it's going to be great if you're just assembling your router sled, but if you've already assembled your router sled and you're maybe having some technical issues, or your bearings aren't sliding correctly, or you're finding it a little bit too hard to push it along, come back to this video and use it for troubleshooting, because I guarantee it will probably help alleviate any issues that you may have getting this thing set up. So the first thing I want to talk about is the core design of this thing. These are actually relatively standard components. They're used in automation, machinery, particularly like CNC machines and 3D printers on a larger scale. There are people that design like homebrew, do-it-yourself CNC machines. They all use these components. They are relatively standard. These are 20 mil rails, which are like 0.78 inch diameter rails, same as the crossbars. And essentially what you're building here with this router sled is a dumb CNC machine. CNC machine in terms of the fact that you've got your long, wide x-axis represented by these long main rails. You've got your y-axis, your back and forth, front to back, whatever you want to call it, represented by your crossbars, and your z-axis or z-axis represented by your router and your router bit that's in that router. Really the only difference is you don't have any servos, stepper motors, control hardware and software to run. It's your brain and your hands moving your router along, leveling your slab, tabletop, charcuterie board, piece of wood, whatever you've got in your sled. So what I want to talk about first is actually all the components you're going to receive in your router sled kit, what they're for, and then we'll get started in our full assembly and some demonstrations. So you've got your main rails, which are the obviously longest part of the kit. And depending on what you order, you may actually have a couple of sets of these, because you can buy the base kit and then you can also buy extensions. So if you have one of our kits that's 4 foot or 6 foot rails and you want to go 10 foot, 12 foot, 24 foot, whatever it is to do longer slabs, you'll get extra sets of these rails, which are shaped at the ends to easily butt together on your workbench, and then you can create an essentially infinite length router sled should you be so inclined to do so. You have your crossbars, which are going to eventually get mounted perpendicular to your main rails. Moving over here, we've got our laser cut and machined components, starting with our crossbar brackets. These are what supports the crossbar mounts and crossbars themselves. We have our main router plate, which is where your router gets mounted, your optional dust collection gets mounted, and of course some of the other linear bearings that we're going to talk about in a second. Moving over here, we have our collars. I don't even use these things, but they do come in the kit. They are stop collars for your main linear rails. So if you were doing, say, juice grooves and you wanted to actually limit where your router was going, or you just want to prevent it from, running off the side of your table, off the end of these, you can mount these to your main rails, tighten them up, and basically create a hard limit. Over here, you've got your cross member mounts, which will attach to the cross member brackets and support the crossbars. Over here, you've got sets of linear bearings. 4 open bearings here and 4 closed bearings here. The closed bearings are the ones that attach to your main rudder plate, and the open bearings are the ones that will attach to your main linear rails to slide along like so. You'll of course get all the screws you'll be required to attach the bearings and these components together. They are 6 mil screws. You'll see that most of them are one length, but you'll have a few of them that are longer, and once I start assembling this, you'll understand why. You'll get an M5 Allen key for using these M6 screws. But just a heads up, if you do need to do any tweaking or adjustments, you'll probably want to have your own set of metric Allen keys, specifically an M2, an M4, as well as that M5 to kind of put everything together. And again, once I start assembling this, you'll see why. Now, in terms of dust collection, if you order the optional dust collection parts, you've got your 2.5 inch universal dust collection mount, which will attach to the main router base. And then you have a strip of thick PVC with some very strong two-sided acrylic tape. And that will essentially act as your dust shroud, and I will get into discussing dust collection shortly. But I also want to talk about what doesn't come in the kit, i.e. what you're going to need to get this whole router sled set up that you're not going to get in the box. So let's move over here and we'll talk about that. So you'll need a sufficiently sized workbench or tabletop. to mount your router sled to. Your router, of course, our system doesn't come with a router. There's a bunch of routers on the market, which is why we pre-designed these holes to fit most full-size routers. Full size is the key here. So this right here is a Bosch 2.25 or 2.5 horsepower router. Not an overly expensive one. I think it's like $250. And it has a half-inch collet adapter here, so you can use half-inch bits. Now, the key thing is you're going to want to use a full-size router. You're not going to want to use a handheld trim router. This is not going to do anything other than leveling paper. It's not going to level a slab, so you definitely want a sufficiently sized, high enough horsepower full-size router. You can definitely get it more powerful than this. I think there's like a Triton one that's like 3.25 or 3.5 horsepower, but they don't really get much more powerful than that, simply because you're limited by your 110 volt 15 amp electrical system that you'd find in your house or shop or whatever, right? So moving on from the router, you of course need your slab leveling bit, or also known as a spoil board bit, because they're often used for CNC machines to level out spoil boards for your CNC. And there's a ton of these on the market. We do not sell them at this time, but they range from $30 to like $200. Now the more expensive ones, this is kind of a mid-range one, but the more expensive ones typically have replaceable carbide blades that you can take out, rotate, put back in to make sure you always have something sharp. Whereas the lower end ones are non-adjustable, and once you've ruined that blade, it's garbage. So invest how you can, use what you can. You can try a bunch of different router bits. The one that we use to determine all of our measurements is this one. I think it's 2.5 inches in diameter. A wider router bit with a wider diameter like this is going to obviously give you slightly more slab leveling space because it is obviously wider. With that said, if you want to get the most versatility out of your router sled, you'll want to get a half-inch collet extension rather, and this is going to allow you to create a longer reach from your router. The collet extension is really only needed if you are mounting your main rails onto some plywood risers, which kind of brings me to the next thing. I've pre-cut these off camera, but essentially they are just 2.5 inch wide, 3/4 inch thick pieces of plywood. And what this is going to do is it's going to allow you to raise up those main rails on the sides of your table. And again, once I start doing the assembly, you'll see why you need them or why you should use them. But obviously, the higher you make your router is going to enable you to do really, really thick slabs. But if you want to do, I don't know, a 1-inch slab or like a charcuterie board or something, your router is going to be too high. So that's where the collet extension comes in, allows you to not have to remove these, and instead you'll be able to reach further down with your router bit to get thinner stock. Alternatively, don't use one of these rails, or just use one, don't use one of these risers, or just use one riser per side, and you can probably get away without this, but you certainly won't get the maximum height ability to actually slab level. So you might only get, say, 2 or 2.5 inch max slab under that router bit before you max it out. Whereas once you add 2 of these, at least in this configuration with this router, I get roughly 3.25. So I could essentially do 3.25 to 1/2 inch with this setup. So last thing is screws. We've got screws for actually mounting the router to the router plate. Might seem obvious that your router would come with screws, but typically they're not long enough, and I will talk about that once we start assembling them. So you'll need router screws to attach the router to the router plate. You'll also need just regular wood or metal screws to attach your linear rails to your workbench. We don't provide them because you may have a limit on length, or you may want to use something like this, or you may want to use some Rampa Tech, adjustable fasteners. There's a lot of options, so we just don't even bother with that. So now that we've talked about everything that you don't get but that you will need, let's start our assembly so you can get leveling some slabs. The first components we're going to assemble in the kit are the cross bar brackets, which are these long 1/2 inch acrylic pieces. You'll have a Crafted Elements logo in the middle, version code at the bottom, and you'll also have 4 holes on each side, but you'll notice that one is offset and tapped for a thread. So this is actually where, the side, that your mounts are going to get attached to. So on this side where my finger is right now is actually the slab leveling side once this is fully assembled. This side over here is the side where you're standing on the outside of your slab leveling table, your workbench. So what we're going to do is we're going to grab our open bearings. Now these bearings are kind of cool because they are anti-dust bearings, which is to say that they've got this rubber gasket here to prevent dust, debris, and whatever from getting into mechanical components. Without that, you could obviously, especially in a slab collection, slab leveler application, get a lot of dust in here, which means you've got to blow it out and oil it every once in a while. Not the end of the world, but these rubber gaskets just help prevent that. But with that said, these rubber gaskets also introduce friction because the gasket kind of grabs onto the linear rail like so. You actually end up introducing a little bit of friction in the system, which means the bearings don't slide as nice. I mean, obviously still movable, but I want to actually look at and demonstrate how to adjust these bearings to make sure they slide appropriately. Because if you assemble this entire thing and you haven't checked the bearings on your rails, you may end up with kind of like a shaky sled or just a little bit more effort to push your sled around, which you don't need. So what I'm going to do is grab my Allen key, and I've got a 2.5 mil Allen key, and I'm going to tighten up the top adjustment on the bearing. I'm going to grab my 3 mil and tighten up the side and then demonstrate how that actually relates in terms of how the bearing moves on your rails. Watch this. Right? Not very smoothly. Okay, so if your bearings are moving like that out of the box, you're going to want to adjust them. So I'm going to leave that one tightened. I'm going to untighten this one to make sure that it has enough play to roll. I'm going to untighten this one, but I'm also going to take off the dust collection component, or rather the anti-dust component of this bearing, because you are definitely free to do this. If you do not care about having to clean these and oil these every once in a while, and you'd rather like a super smooth router sled, you are certainly free to remove these rubber gaskets, and I will visually show you what the difference is, because that's obviously going to correlate to how much effort you're putting into leveling your slab. If it were me, I would probably just leave the anti-dust gaskets on, but it's your sled, your setup, you can tweak it and use it as you'd like. So I think this was the tightened one. So in this not so scientific demonstration, I'm just going to show you the differences. We've got our bearing that our Allen key adjustments have been tightened. We've still got our rubber gaskets on. And motion, it works, but it's not that great. We've got our bearing that we've loosened the adjustments on, and it's just much smoother. I know it doesn't move any further, but it rolls much smoother with less friction. You can tell, hard to tell on camera. We've got the exact same bearing loosened without the dust collection, and it's gone. So you can see just by what I'm just demonstrating there's a significant difference when that dust gasket is on, and it's completely up to you if you would rather be cleaning your bearings out or if you want to just prevent them from getting gunked up for the sake of having smoother motion. So once you've run all 4 bearings down your rails and made sure that they move universally smoothly and don't have any excess tension, you are ready to actually start your assembly. So once you've made sure that your open linear bearings roll nice and smoothly, or as smooth as possible at least, with or without that rubber gasket on your main linear rail, you can now attach them to your crossmember bar supports. So I'm going to go ahead and assemble them right now so you can see. I'll do one at a time. You're going to grab 2 of your linear bearings, and you're going to align them in as such that your bar would essentially be going this way. So placing them like so, you're then going to grab your crossbar mounts. Now, you'll notice that they have an Allen key adjustment on one side. You're going to want to ideally keep that Allen key adjustment pointing out, right? Because if you have it inside like this, when you come in to tighten them, you're going to have to do it this way, which is going to kind of be in the way, and it's just easier if they are both pointing out. You can adjust them and tighten them from the outside. Take my word for it. So what you're going to do is you're going to just loosely put your screws in, short ones first. So the short ones are going to go in the first 2 positions and the offset threaded position. The long screw is what goes through your mount, through the acrylic and into the bearing, which is here. And it's just make sure you follow along there, guys, because you want to have that long screw attaching to your mount bringing your mount together through your acrylic and into the bearing. That's the entire point of having that long screw. The other 3 screws are the short ones. And if you want to cheat, get a 5mm bit and just do this instead of using your Allen key. Now, one thing to keep in mind is that there is a little bit of play in these holes. So if I untighten these screws where the mount brings the unit together, you'll see that I can have a little bit of, I don't want to say wobbliness, but just a fraction of play. Now, it's going to be hard to see on camera, but if I tighten it in such a way that you've got the mount flush with this, but inside here, that's going to be reflected in the alignment of your bar. So you want to make sure before you tighten the mount down that you've got essentially a universal gap, or rather that this is completely as flush as possible to the side of acrylic before you actually tighten these, just to guarantee that they're straight, because if it's off at all, you're going to feel it when you run your router sled across your table. All right, there's one done. Grab another one, line up our bearings, grab our mounts, Allen key adjustment to the outside, long screw on this outer corner of each, and the rest are your short screws. So moving on to our router base plate, we have our main router mount with all these pre-drilled holes for the common full-size routers we spoke about. We've got our area, which has threaded holes for our dust collection boot. We've got our Crafted Elements logo, so obviously this is going to be a visual, this side up, so to speak. So if it's like this, you've got it the wrong way. Crafted Elements logo up, and you've got 4 sets of 4 holes, which is where our bearings mount to. Now, our bearings mount to the top along with your router, and now the reason we do that is because it's going to keep the bottom open to obviously allow for a complete seal of your dust collection shroud should you wish to use one, but it's also going to keep your hands from underneath here, because you're going to be able to grab this or grab your router to push it along, unlike grabbing it from underneath and getting your hand close to that giant spinning bit. So we're going to flip this guy over, we're going to set our bearings down, and we're going to grab all of our short screws and attach the bearings. There are no long screws in this particular configuration. They are all equally sized short screws, and this is probably a good point to say that we do actually include extra screws in each kit. So if you end up with screws at the end, don't fret. They're probably just the extra ones in case you lose them or in case we miscounted. So our bearings are attached. We can now move on to attaching our router. So I'm going to go ahead and put that to the side and grab our router. So this is a Bosch 2¼ horsepower router. They come, generally any router comes with your base plate and your handles attached. Because of the way we've designed our system, you probably are going to have to remove your handles, and I've never seen a router where you couldn't remove the handles, so hopefully your router also has that ability, because you want to have obviously the maximum amount of flex. Obviously with those handles on, I can't mount it that way. So once you remove your handles, you can proceed with removing your base plate, and then you can actually mount this to our router plate. So most routers are going to come with an existing base plate and some screws, and you can just remove that base plate, because generally that's what is required to mount your router to like a router table. So we're doing kind of the same thing here. We're going to take the base plate off. So when I take those screws off, you'll see that they obviously fit the threads on the body of this router, but they're clearly not going to be long enough to go through 1/2 inch acrylic and back in there. So this is kind of where the challenging part comes. You can get obviously these types of screws at your local hardware store, machine shop, or whatever. However, my recommendation is honestly to cheat. Go on Amazon, buy a universal router base plate like this guy, and it literally comes with a whole bag of common size screws. So you may still end up with screws that are not quite long enough to go through your acrylic. You know, these guys obviously will go through the acrylic, but then you've only got 1/8 an inch or so of thread, which is certainly not enough to safely hold this in place in such a demanding application. You definitely want to make sure that you've got at least 1/4 inch of thread going through into your actual router base to keep it attached to your base. So I know from the diagram that we provide on our website and PDF file that our hole configuration for this Bosch router is A. Each one of these holes has a letter represented to it, and if you flip it over in such that the bearings are now on the bottom, those letters will be the correct way up, indicating that you're going to want to screw from this side down and have your router on this side. So to demonstrate, I'm going to show you what I mean. I'm going to line up holes A with my router plate here and just kind of figure out my bearings here. So I've got a hole here, and a hole here. I'm using these screws, pretty simple. All I'm going to do is grab a countersink bit, or you can use a regular drill bit, just don't go all the way through this. I'm going to go down anywhere between 1/8 and 1/4 inch to make sure that these screws are now long enough to go through. Again, this countersinking process is not required if your screws are long enough. Don't worry about your screws protruding past the acrylic. Obviously these guys do, so it makes no difference. I'm only doing it because I need to get a little bit more length out of those screws. All right, now I can go use my screws and my partially countersinked holes, which now gives me enough thread on the other side to attach this router. Now that we've got our router attached, our bearings attached, everything's hunky-dory, you could choose at this point to attach your dust boot, which is this guy. You're going to grab the screws that come with your dust boot and just thread them into the threaded parts of the router base plate and attach them just like we did the router. Now at this point of the installation, I could also attach the shroud, but I'm actually not going to, strictly because it's easier to demonstrate assembly and operation of the router and the way the bit's working on camera without this thing in place. However, if you weren't actually trying to demonstrate this like I am on video, you would just essentially take your 2A tape off and then start at one corner and thread it all the way around, or not thread it all the way around, but move it all the way around the perimeter, attaching it to the 1/2 inch acrylic. And then once you've done that, at your corners, you would take some scissors or snips or whatever you got in your shop and go roughly 1 inch to 1.5 inches up. That cut is essentially going to give each of these sidewalls independence to flex and move. If you leave it like this, you're going to end up with crunching plastic. So you definitely want to just make your quick slit on each corner once you've attached this. But again, I'm not attaching this because I want to demonstrate the actual router. While we're on the topic of dust collection, I just really want to touch base on how important it is to wear a respirator or a mask with or without dust collection, because these things are still going to generate a lot of dust, a lot of debris, and even with dust collection on and your shroud on, the key is what we are trying to collect is the fine particles you can't see. Those heavy, big, spindly, spirally things that are going to come off your router bit are probably not going to get picked up by this dust collection system or even dust collection system on any competing units. In fact, I used one of the Woodpecker units years back, and even with my dust collection on, I would say 50% of what the mess I made still was on the table. So just know that dust collection in these things is at most 50 to 60% efficient. What we're trying to do is create a cavity a cavity of air that your dust collector can suck out the fine particles that are floating around in the air so they don't get in your lungs. You're not trying to collect all the debris that these things make. So these things do make a lot of debris, especially if you're leveling a big slab or a big piece of wood. So just know that regardless of dust collection or not, wear a mask and you're going to have to clean up, which is why I'm kind of impartial to the entire dust collection thing on here. I figure if you're going to clean it up anyway and you're wearing a mask, not really convinced it's actually that important to have these adapters. Further to that, most people who are using these might be operating out of their garage, their home shop, and you don't have, a 230 volt high CFM industrial dust collector anyway. You're using something more, I don't want to say consumer, but something, higher end consumer or entry level industrial, which doesn't have the airflow regardless to collect all the dust that you need anyway. So that's my 2 cents on dust collection, but right now we're going to bring all these components to the table. We're going to bring our rails to the table. We're going to assemble things over there and get this thing finally fully assembled. I hope you're excited. Let's go. All right, so we're going to go ahead and start mounting our rails to our workbench. Now, when you're using a workbench, it might already be one that's already in your shop, but the key is that it needs to be straight and flat. And I use the word straight and flat versus level because in the end, let's say your floor is not level and your workbench is inherently not level, your rails, your metal rails are going to be attached to your workbench and be equally not level. So as long as the distance between your router bit and your tabletop is equal universally, level doesn't really matter. Straight is what matters. If you have a big, cupping or bowing in your workbench or something like that, that's not really an ideal surface to use for this type of application. You can certainly get around it, using shims and stuff, but to get the best quality finish and the most efficiency, start with a flat, straight tabletop or workbench top. So I've already got my risers here pre-cut that I did off camera, and I mentioned them earlier in this video. These guys are 2.5 inches wide. You can typically get go up to 5 inches wide without protruding on slab leveling space. What I mean by that is, if these are wider, it's not necessarily going to matter up to a certain point, because remember, your slab leveler doesn't do the exact same size slab as the dimensions of the leveler. Put it simply, if you have a 6 foot by 40 inch slab leveler, okay, so you're buying a 72 inch by 40 inch slab leveler, that more or less is saying that it's going to occupy 6 feet by 40 inches of space. So you're going to need roughly an equivalent size tabletop. It does not mean it's going to level a 6 foot by 40 inch slab. Okay, very, very important to know that. You have to take into account the width of your rails, the width of the bearings and all that. Essentially what it works down to is, if you want to do the math, your rail length minus 8.5 inches is the maximum slab width you're going to be able to do, assuming you're using a 2.5 inch diameter slab leveling or spoil board bit. Okay, so whatever the length of your total rails are minus 8.5 inches, if you're using that 2.5 inch bit, is the maximum amount of slab length you can do. And in terms of width, the y-axis, so to speak, the front and back, when you're moving your slab leveler back and forth, it's the crossbar length, so those bars that don't have mounts on them, minus 9.75. There's going to be some play in these dimensions, because if you use a wider router bit or a lower diameter router bit, you're going to have more or less slab leveling space, but in general, you should be using those numbers to calculate the maximum slab leveling ability you have. Now keep in mind, you can always slide your slab down and support it as long as you're maintaining the same horizontal area. So if you've got a long slab, it doesn't mean you can't level it with this slab leveler. It just means you're going to have to then move it and keep it at that same level to continue your slab leveling, right? So there's a little bit of play in these things. Now, when we're going back to talk about these mounts, I've got 2 3/4 inch pieces of plywood for each side, effectively giving me 1.5 inches raised. And I'm doing that so I can raise the outer rails, effectively raising my entire router up to allow me to do thicker slabs. If you don't plan on doing 3 inch, 4 inch slabs, you don't necessarily need this thickness of rails. With this configuration, with the router bit I've chose, with my router, we've got just over 3¼ inch maximum height of a slab when you're using these two risers. Take away 3/4 inches of thickness, then you can take away 3/4 inches from that dimension. So if I've had 3¼ I'm now down to 2½ inch maximum slab with one single 3/4 inch riser. If I take that away, I'm down to 1.5 to 1.75 inches. So if you're doing charcuterie boards or thin stock, you don't even need these risers. If you're doing tables and thicker pieces, you definitely want these risers. Now, to give me the most flexibility, I've gone ahead and pre-drilled holes in my risers and pre-drilled holes in my top and used threaded inserts in my workbench. So that gives me the ability to quickly attach and detach these things, because if you're like most, shop warriors or people that are working at your home or your garage or small space, space is at a minimum. You can't dedicate an entire workbench to just slab leveling. It has other purposes. So if you want to use this method, I highly recommend it. Otherwise, you can just take your risers, screw them down to your workbench and leave them in place, or unscrew them if you actually need to unscrew them. But the best, most efficient way to do this is with the threaded inserts and hex screws if you want to make them, if you're going to be removing them and detaching them and attaching them regularly. So what I'm going to do is I'm going to go get my screws and I'm going to attach these guys. With our risers now in place, we can get our main rails and line them up. The distance between the inner section of the rail, so the distance between the inner parts of the rail, should be at most the crossbar length minus 3 inches. So if I've got a 40-inch crossbar, take away 3 inches, that's 37 inches, as in the distance between here and the other rail on the inside should be at most 37 inches. You can make it less. Let's say you've got 40-inch crossbars but only a 24-inch wide table, not a problem. Let's pretend this was a 24-inch wide table and the crossbars sat approximately there. It just means that the crossbars are going to overhang the table. You can cut them down if you want, not a big deal, but what I'm getting at is the length of your crossbar minus 3 inches is the distance you want these rails apart, and you want to triple check that. If you want, cut a piece of wood that's exactly the same length, that 37 inches or whatever it may be that you need to space these apart, and slide it along to make sure you're relatively equal. These need to be as parallel to each other as possible. If you've got one crossbar, this is obviously blown up or accentuated. If you've got one crossbar on an angle like this, you're going to get a nice smooth linear roll on your router sled, and it's going to get really tight as the distance gets further apart. And that's one way to tell, in fact, that you've lined up your rails incorrectly, if you have nice motion on one side, not so nice motion on the other side. So I'm going to go ahead and get a tape measure. Because I've got a 40-inch bar, I'm going to measure these and make sure they're 37 inches apart, and then we're going to screw them down. Now after you fix down one side and put a couple of screws on the other side, it'd be generally a good idea to test the fitment of everything, and then at the end finish off screwing everything together. So I'm going to go ahead and get our cross member or crossbar braces, slide them on, and we're going to attach everything together. Make sure it slides correctly and there's no tension anywhere, and then assuming there is not, we can then go and screw and tighten everything down. So first up is our crossbar brackets, and we're going to make sure that we're assembling them so that when we look at the router sled, we're seeing the Crafted Elements logo appropriately, not upside down. In other words, you're going to make sure that the mounts are on the inside of the router sled, not on the outside. So like this. All right, so you can see they roll nicely, and of course, as we addressed earlier in the video, we can make them roll even smoother if we took the the rubber gaskets off, but we then lose the anti-dust feature of the bearings. Completely up to you what you want to do and what you want to prioritize. So now I'm going to get my router base and router. Go ahead and loosen our mounts to make sure that they don't interfere with sliding the bars through initially. The first time that you actually assemble this, it's a little bit clunky and awkward. But remember, once it's actually assembled, this entire sub-assembly, the carriage, so to speak, comes on and off. Like, you don't have to do this every time. This is a one-time assembly deal. I'm going to grab our crossbars, run them through our router base component, through the bearings here. And then we're going to take the sub-assembly, throw it in each side of our brackets. Now, here's the key. These bars need to protrude through the mounts 1 inch. Okay? You might be okay with 3/4 inches, but really 1 inch is what we're kind of, everything's measured based on our website and all our specifications. All right, so you've got 1 inch, 1 inch. You can get away with a little more or a little less. It's not that important, but it definitely needs to be a notable way past the mount. If you just line this bar, edge of this bar up flush with the edge of this mount, you introduce the ability for it to skew. So essentially the bars to go like this or like this instead of stay straight. Having them protrude a little bit allows them to stay really straight, which obviously is important in this type of application. So I'm tightening up one side. I'm going to walk around here. I've got a little bit more than 1 inch on this side, which is fine just because of the size of my table. Makes no difference. Before I tighten these guys up, I'm going to make sure everything slides nice. So we're not seeing any problems here at all. I'm getting a little bit more tension than I should here, which means probably that these bearings are not exactly straight. Not a problem. We're going to continue to assemble this thing, and then we're going to take the sub-assembly off, flip it around, loosen up everything so the bearings can straighten out, and then we'll tighten it and you'll see the difference. So just watch. Okay? A little bit of friction there, not a big deal. We're going to go ahead and tighten down our sub-assembly because it runs this way, X to Y, or rather X in the X-axis, perfectly fine without getting caught up or, jumping around. So what I'm going to do now is to address this issue, slide it off, turn it around, and we're just going to loosen up these screws until we get it sliding correctly, which will fix any sort of tension problems we might have. You can see automatically reducing those screws. We have next to no play now. We can literally just roll this back and forth. So it was really just that maybe 1 or 2 of these bearings were just off a little bit, and then we tighten the screws. But by doing it this way, tweaking it a little bit, and then finally tightening everything up, we're going to have a nice rolling sled. Huge difference, right? So now we've got good motion in the X and Y axis. We know that our bars are spaced apart. We can go ahead and finish screwing these all together and making sure everything's tight. Now, as I alluded to earlier in this assembly video, there is the option, of course, to get a longer router sled by getting extension rails like this, and now would be the time to install them. Obviously, this table is not long enough to support additional rails. However, it quite literally is as easy as butting them up, making sure you're nice and level. but butting them right up against each other, lining them up, screwing it down, doing the same thing, spacing out the rails just like we did these ones to effectively give you the length that you want. So again, if you've bought the extension rails, go ahead and install them now on your tabletop. Since we've already spaced everything out and everything works, we can now install the rest of the screws on our main rails because they don't need to be adjusted anymore. Now, if you're planning on keeping this thing in place and not going to be removing that subcarriage very often, you can use these stops, as I mentioned earlier in the video. Literally, they're just little collars that you can attach to these bars and tighten down, and then tighten up with your Allen key. And this will prevent the router sled subassembly, as that carriage that slides back and forth, basically, from flying off the end of your rails. We are nearly at the point where we actually can start doing some projects with this thing, but we just need to attach, of course, our slab leveling bit, and if needed, our collet extension. So what I'm going to demonstrate for you guys is the difference between this router in its fully down position with the bit attached here. So I'm going to grab here, and I'm going to attach this to the router. Okay, so we've tightened up this bit and there's no collet extension. This is the highest it's going to go. A little bit awkward for me to get a measuring tape under here, but it's almost 3¼ inches. Now, the problem lies when we want to do a thin board. Bringing this all the way down to its maximum distance, we don't have the reach to do something thin. We're now at 2½. We can obviously untighten the router bit, lower it a little bit, and tighten it again, maybe get ½ inch out of there. But what happens if you want to do 1 inch or 1½ inch boards and still have these risers in place? That's where this collet extension is going to come in. So I'm going to take this off, I'm going to put the collet extension on, and you can see the difference. So now you can see with that collet extension on and our ½ inch slab leveling bit attached to that collet, even with the router at its maximum height, we still have this ability. We can even go even lower. I'm not going to hit the table here, but you can see that we can just keep going down and, you know, level things that are, heck, probably ½ inch at this point, right? So again, the entire point of me demonstrating this to you is to show you that if you use these risers, it's much easier to get the collet extension and use that for thinner pieces of work rather than removing the risers, reassembling the whole thing. It should also be noted that there is, of course, a way to still use the router sled with the risers and do thin stock and thick stock, which is to essentially bring your piece up to the router bit instead of bringing your piece down with a collet extension. And to do that, you'd simply use plywood. Use something dimensionally stable, something that's not warped or cupping, you know what I mean? MDF works really well for that, and that's the reason why MDF is used frequently on CNC machines, because it's flat to begin with. You can layer it, so you get 2 ½ inch pieces to make an inch, 2 3/4 inch pieces to make an 1.5 inches. And effectively, when you put that down first, mount that to your table, and then you mount your piece, your charcuterie board, your table, your slab, whatever it is, to that plywood, and effectively you're bringing it up closer to the router bit, avoiding the use of the collet extension. There really isn't a general rule here that you should be using the collet extension, you should be using plywood. You know, do what is convenient for you. If you've got storage area for the plywood, use the plywood. If you do want to avoid having to attach the collet extension, use the plywood. If you don't want to have plywood, use the collet extension. It really makes no difference. The the key is that you want to maintain the most flexibility without having to take your entire sled apart, without having to replace these rails, lower the rails. You want to be able to just adjust your stock height easily and quickly, and that's where the collet extension or the plywood riser would come into play. All right, folks, that's really it. We've now completed the assembly of this. We've attached our router, we've attached our router bit. At this point, if you have dust collection, you attach your dust collection hose and that PVC dust collection shroud that we talked about earlier. I'm going to leave it like this as I demonstrate some examples of hold downs. Before we get into that, I just want to talk about some troubleshooting tips. I did allude to some of them earlier in this assembly video, but it really comes down to alignment. That is really, if you're getting a poor finish on your slab, or the thing's not rolling correctly this way or this way, it has to do with alignment. Whether it's the bars out of the alignment or the bearings out of the alignment, that is really what you're going to have to isolate. So if you've got problems rolling on the x-axis or your wide length side to side, it is almost always either going to be the bars at a different distance from each other, or these mounts not square. Again, we talked about earlier in the video, making sure that these mounts that the bar is actually attached to are nice, either flush or at least the same distance on the sides, so they aren't keeping the bars at an angle. So to test that, it's pretty simple. You don't have to take the entire thing apart. Just grab your Allen key and then loosen up these mounts to make sure that they are indeed perfectly straight. All right, so keep them a little bit loose. You don't need to take the screws all the way out. Adjust them if you need to. If your bearing's a little off a little bit, take these screws out a little bit as well. Make sure everything's straight, put it all back into place, and then retighten it. Now, if after doing that you're still having issues regarding the fluidity of motion on the x-axis, it may just be the friction caused by those anti-dust rubber gaskets that we have on our bearings. You're certainly welcome to remove those. You don't even have to take the whole sled apart. Grab a small starred screwdriver and just from here, take off the rubber gaskets using your screwdriver, throw them away or put them in a box, and you will obviously have a much smoother array of motion. I just choose to keep them on because in this case, in this application, you're generating a lot of dust, and I'd rather not see them inside the bearings. Not the end of the world, of course, if that happens. You can blow them out with an air compressor and then oil them up with WD-40 or whatever other machine oil lubricant you have and get that motion back, but I'd just rather not do that. So I keep my dust boots on. Up to you what you want to do if you value the easier range of motion or lack of dust in your bearings. Now, when it comes to the y-axis, rather the pushing forward and back or your up and down, whatever you want to refer to it as, same thing is going to apply. You're either going to have an issue with the alignment of your crossbars or you're going to have an issue with the way your bearings here are positioned. So again, if it's a crossbar issue, it's going to be starting at the mounts. Look at the mounts, make sure that they're straight, make sure that they're flush to keep these bars perfectly in line. Make sure that your crossbars are protruding at least half an inch, 3/4 inch to half an inch or more to make sure you don't get that skewing. If you have these crossbars lined up with the end of here and flush with the mounts, you may have a tendency to have skewing of those bars, which is certainly not going to do you any favors in terms of the motion department. If that fails, take the entire thing off the sled, flip it over like I did earlier in the installation video, loosen up all your screws, check the motion, and if it's fine, you've won. Put it all back together, tighten it back together, and you'll have that nice range of motion. Just like these bearings also have those protectors on them, and you are certainly free to remove them. The only case is that in the case of these guys, if you want to remove these protectors, you actually have to take this entire thing off and take these bars out. Because they are fully closed bearings, so just how it is, or you're going to end up breaking the protectors. Either way, you want to increase the range of motion and the easiness of motion. Here, you can take those gaskets off as well. What I want to discuss now is actual hold down methods for wood. You've got your router sled, you're ready to rock, but let's just make sure that we're doing this properly and safely so you're going to get the best result. Now, if you've got something like a river table or a relatively nice piece of finished wood that you're just trying to reduce, it's going to be really easy because it's super flat. It's going to sit flat in your table and holding it down is not a problem. If you've got kind of a wonky piece of live edge which is not level on either side, well, then that's when it gets a little bit more difficult, and you're going to kind of maybe have to use a couple of these methods in order to successfully get that leveled. So what I mean by that is, if you've got something that is completely wonky, or rather it is just completely natural on both sides, you're going to want to determine what level is going to be, because neither side is level to begin with. So you have to decide for yourself what that's going to be, and that's going to involve attaching it to the table using shims or another method, depending on how off it is, to prop it up and support it in such a way that it's not going to move and rock around. So as you have something like that, between shims, hot glue, and screw downs, and even clamps, we're going to be able to get that to a point where you can actually start leveling it. Now, once you've leveled one side, you get rid of all that and you flip it back over, and holding down a flat piece on the other side is going to be really, really easy, so you can flatten the unflattened side, if that makes sense. And while we're on the topic of hold down methods, I want to talk about plywood, because especially if you've got these risers installed and you've raised those edge rails up, and especially if you are not using a collet extension, your bit's obviously going to be a little bit higher. So if you want to do smaller, thinner stock, if you want to do charcuterie boards, things like that, I actually really recommend the plywood method. And essentially you're just using a piece of plywood. You could use MDF or something generally stable, flat, to actually mount your plywood within your slab leveling area first, mount that down to your table, and then mount down your piece to that, or hot glue it, or whatever you want. So essentially you're raising up your material instead of lowering your router bit, but you're also giving yourself an additional piece of plywood, essentially a spoil board, that you can waste. You can drill into it, you can glue to it, you can attach things to it, and when it's all messed up, after many, many uses, you can throw it away and put a new one down. So that's also something that is worthwhile mentioning, because I guarantee that, especially if you're using thinner stock and you want to avoid using that collet, the collet extension rather, this is probably a good way to go. And you can of course stack plywood. You can get 1/2 inch MDF, 3/4 inch MDF, and just get as tall or as thin as you want. What I want to demonstrate now is using this for a river table. I've got a 24 by 48 inch river table, coffee table, that I've been wanting to level out. And I'm going to demonstrate a couple of different hold down methods we can use for something that's generally flat on one side to begin with, but that kind of applies to anything else. All right, so let's get the river table. Now remember that you do have a limited range of slab leveling ability. You're not going to be able to put the slab or your piece of wood over here and reach that, and I'll demonstrate why now. Right? Your bit only goes to about there, which is why we talked about those offsets. So when you're mounting your piece, you're pretty much wanting to mount it in the center, both in the x-axis and the y-axis, to make sure you have enough range of motion to get the entire piece. So in this case we do. We've got our bit a little bit low there. But what we're going to do is take this, move this out of the way, and then we'll work on leveling or flattening this piece. So mounting this is relatively easy, because most river tables are generally flat on one side, because you've got your epoxy, your wood, and everything that's on the bottom that's created a flat edge. It's usually the top part that's got the wood, the epoxy, and maybe whatever your hold down method that needs to be leveled. So this is actually a pretty easy use case, which is why I'm starting with this. Now, if you weren't going for optics and visualization like me, you wouldn't have put resin on your table, because this is essentially a pretty slippery table. Not my finest thought, but anyway, it looked good at the time. So we're going to go ahead and actually have to mount this. If this was a piece of wood or something like with a little bit of friction, or less friction, more friction rather, you might not even have to mount a big slab or river table, because it might weigh so much to begin with that you can literally just let it sit there and go to town on it. But again, that's going to be up to your discretion. Don't necessarily take my advice for it. It's going to be dependent on the weight of your slab, the amount of friction on your table. But what I actually like to do is take these little guys, just little squares. You can get them from Amazon. I think this is like duraluminum. I think it's like $20 or $30 a piece. And in the case of using it with a river table or charcuterie board, it's super easy, because you can do this at one side there and one side there, screw this down, and that slab is not going anywhere. So I'm not going to screw this down right now, because I also want to discuss another method which is less intrusive to the surface of your table, and that is plywood and clamping. Again, we are lucky with a flat edge, and again, a lot of live edge you're going to get, especially slabs, are going to be flat to begin with, right? Or rather have a flat edge to begin with. So this is pretty obvious. But butting it up against your piece with a piece of scrap plywood or wood that is lower than the piece, right? You don't want it up here because you're going to end up flattening your hold down method. But if you do that, grab your clamps, clamp it down on both, and do it on both sides, you are again going to have generally good grip on that slab. Putting another piece here, you'd have the exact same thing. So you can use plywood or spare wood and clamps to basically butt up against your piece and hold it in place while you're leveling it. But let's say that the project you're leveling is more difficult. It's not a charcuterie board or a river table or a generally flat piece of wood to begin with, and it's, you know, cupped and warped and flapped on both sides. Well, that is really just going to require your creativity and discretion, using a combination of wood shims to make sure it's level, and not a glue gun like this, but get a big glue gun with bigger glue sticks so you can put globs of glue down. Gluing it to the table is actually really, really efficient, especially if it's an awkward sized piece like a cookie. Putting a bunch of glue in different sections is going to keep, and letting it dry before you actually slab level it and run it through the router, is going to keep it down pretty darn good. As long as that piece of wood is stable and staying in place and that you can't, you know, easily shake it, that's going to be sufficient enough. Now keep in mind, it's also a function of how deep you go with your slab leveling bit. This is not a one-shot done deal. So you don't set your level that you want to take a 1/4 inch off, take a 1/4 inch down and just go. You will not only strain your router, possibly burn it out, it's going to be a disaster, right? When you're doing these, especially if you're taking off more than, let's say, 1/8 of an inch, you're doing it in multiple passes. I wouldn't really go more than 1/8 of an inch on a softwood with a good router bit or a slab leveling bit. So basically what I'm saying is, especially in the case of this river table, we've got some high parts here. This is walnut, and we've got some low parts here. This is not going to be a one-shot done thing. We're going to probably just get the surface. We're going to do the entire surface, maybe a 1/16th or 32nd of an inch off, lower the router bit, do the whole thing again. This will probably take 3 passes to do, just like a CNC machine. If you're using a CNC machine to do this, you also wouldn't do it in one pass. It would do the entire thing, probably starting at the center, going around in 3, possibly 4 passes before it actually gets to a point where it's sufficiently level. So what I'm going to do is put my mask on, use my hold down methods, strap this boy in, and we're going to level it and see how it works. Before we get started here, I want to explain something about how you actually use this. It might seem pretty obvious, you know, you move it back and forth, yada, yada, yada. However, if you're used to operating a handheld router or plunge router, you're almost always doing this, right? You're grabbing the router, or you're going to want to do like this, pushing it down and pushing it. Seems obvious, seems to be the most comfortable way to do it. However, that is not always the case, especially with the longer crossbars. I want to say that again, because if you've got really long crossbars, we offer like 60-inch or 5-foot wide crossbars, they can actually flex as the router gets to the middle, especially if you're putting downward pressure, even the slightest amount of pressure on your router. So the key is, when you're moving this thing back and forth, you want to push it either like this or pull it, or use your hands and grab the bearings. Okay, these linear bearings, they're really, really handy. You don't have to go underneath and grab this. Just keep your hands the safe way, keep them on the linear bearings, or pushing forward and backward, not putting downward pressure on the router. If you put downward pressure on the router and these bars end up bending when the router gets to the middle, it's going to show in your slab, right? You're going to have a lower area. I mean, a fractional amount lower, but still a lower area of your piece of wood that you're then going to have to fix by sanding it, which is not fun. So best case, slide back and forth, grab the bearings, grab the router if you need to, but just make sure you're not putting any downward pressure on it, and be conscious of the weight you're putting into this, because you do not want those bars flexing.
created a nice little mess here. As you can see, got that first layer down, and in the case of this particular piece, you can see that this level was actually, or rather this thickness on this side was higher than this side. This whole process maybe took me about 4 or 5 minutes. That is way too much material for a dust collector to suck up in 4 minutes. All right, round 2. So the second pass down, we've got almost completely acceptable. Like I said, we're gonna have to do 3 passes on this one as I anticipated. Got a little bit of epoxy left here, got an unlevel piece here, and then we've got a little epoxy left here. However, I wanna show you something. Here is a part where I went through much faster with that router set. I basically went, mwah, and look what happened. We tore out the epoxy. So one of the things you wanna be mindful of is not only the router speed, but the speed that you're actually moving that thing back and forth. Generally, I will run these things at a high router speed, especially if you have adjustable router. I'm running it at speed 6 right now, which is basically the maximum speed that I'll get out of that router. But you want to make sure, particularly with really hard woods and epoxy, that you're not pushing it too fast. If you push it too fast, especially on epoxy, you get this kind of chipping and tear out. Not a big deal. We can fill that with clear epoxy and no one will even notice. But to avoid that and get a nice finish like this, just be mindful of your speed. The next thing is going too slow is also a problem. If you go too slow and you let the bit run on the surface of wood, you'll actually end up with burn marks.
All right, gone over this slab 3 times. It's basically ready for finishing. Of course, you got all the machine marks on it, so you're gonna have to go ahead and, there's the other side, could also plane the other side if you want to level that out. But what I actually want to show you is just how easy it is to remove this thing, especially once you've installed, if you've installed, the threaded inserts and bolts into your tabletop like I have. I highly recommend you do so because it makes your life a little bit easier and makes it so much easier to attach and detach this from the table. Case in point, let's go. You put your router sled sub-assembly away just like that. I'm going to go ahead and grab my drill. And again, I've got those threaded inserts in my workbench, and I'm just using standard hex head screws. Makes your job a heck of a lot easier to attach and detach these plywood risers. It is the plywood risers that are attached with these screws. The actual metal rail here is only attached to plywood risers. So I can literally move this entire assembly once I detach these screws. And put your rails aside. And you've reclaimed your workbench, which is going to be particularly handy if you're working in a small space and you don't have a dedicated area just for a slab leveler. You can use your existing workbench and reattach or detach that slab leveling mechanism whenever you actually need it within a minute 30 seconds. So I hope you found this video on the Crafted Elements router sled assembly and demonstration useful and informative. If you haven't already purchased a Crafted Elements router sled and are now interested in doing so, you can of course go to craftedelements.com, click on the router sled's link at the top of the menu, and find out more about this product and the accessories we offer for it. If you already have purchased a Crafted Elements router sled and you're getting ready to assemble it, best of luck. I know you're going to have a lot of fun with it and it's going to make your life so much easier. You're going to wonder how you live without it. Now with that said, if you have any problems operating it, assembling it, or if you have some issues and you need to tweak it, definitely leave a comment in this video below or contact us via our website. You can go to craftedelements.com and click on the contact button, fill out the form, and someone will help you as soon as possible. Once again, guys, thank you for watching this video, and as always, happy making.